The CCP curriculum encounters systems in numerous ways, most immediately in the climate system. The distinctions addressed in this section depend on spatial and temporal boundaries associated with each term. So we'll define system as a regularly interacting or interdependent group of items forming a unified whole. And the first type of system we want to talk to you about is the climate system, a highly complex system consisting of 5 major components: the atmosphere, including gases and particles, the hydrosphere, liquid water, the cryosphere, frozen water, the lithosphere, solid earth, the biosphere, all forms of life, and of course the interactions amongst these components. The first important distinction in terminology is between weather and climate. For example, in this picture taken in the Arizona desert, we can see both climate and weather. It's typically hot and dry here, that would be climate, but the region does occasionally receive rain and or cold spells, which would be weather. I recently went on a golf trip with a group of friends, and it was cold and rainy for 2 of the days and hot and dry for the rest of the trip. Just because we expect it to be hot and dry doesn't mean we actually get it at all times. So weather and climate are related, but they're not the same thing. People often confuse the two. So let's examine the difference between these two concepts. Weather is what is happening right now outside your window, atmospheric conditions that you can see, feel, and measure at a given time and place are weather. But you can't touch climate. You can describe it as long-term averages using words and numbers. Weather clearly is local and short-term. It's the state of the atmosphere at a particular place during a short period of time. Climate is long-term, but it can refer to spatial locations that can range from local conditions to regional, to national, or to the global state of the climate system. A typical time frame for defining climate from weather statistics would be about 30 years. So by analogy, if we thought about it in the context of baseball or softball, it's hard to predict the result of any given at-bat for a baseball or softball player. But a team manager might feel more comfortable making a decision on what batter or pitcher to use in a particular circumstance based upon that player's career data. You might think of that as the climate. This analogy helps us think about the key differences between a meteorologist who tells us about weather we can expect today or in the next few days, and climatologists who tell us about what we can expect in certain places and or at certain times of year. So coming back to the baseball analogy, if a given at bat is like weather, then the batter's career statistics might be like climate. So let's talk about the key influences of climate. Climate is influenced by latitude, which determines annual exposure to sunlight, altitude, which with higher elevations tend to be cooler and lower elevations warmer, location, including what's upwind, like oceans, lakes, plains, and mountains, and cloudiness, humidity, and wind can influence temperature and precipitation. In summary, characterizations of climate include the average conditions for specific time of the year, spatial scale being described like local, regional, or global, and the temporal scale, meaning the period of interest compared to some sort of baseline period. But climate is also more than the long-term average of weather. It's the state of the climate system influences the odds that certain types of weather are more or less likely to happen. And so if you think of that in another analogy, like an old-fashioned pinball game, determining which bin the ball will end up when you shoot it is a lot like weather. On any single launch of the ball, it's hard to predict where the ball will land, like weather. Launch the ball 100 times and record where it lands, and you begin to produce a quote-unquote climatology, which is an average distribution of the endpoints. But to illustrate how the climate system influences the odds of certain types of weather, suppose you altered the game in certain ways, like increasing the speed of the launch, or removing one or two of the nails from the left side of the game, or even perhaps tilting the machine slightly to the left. These sorts of changes would affect the average distribution of the ball's endpoints on the next 100 launches.